I just have a few minutes here to talk about how we get floats in the water. And we have some experience over a bunch of years from SOCOM, so I'll be drawing heavily on that. There's a ship and there's a tech getting a float ready to go. We have a tension between our objective of getting 1,000 floats globally, internationally, and 500 floats in GO-BGC, distributed pretty randomly over the world ocean. We have to do that through actual cruises that aren't all over the world ocean and every year and every place when you want them. And we also have to match that to how many floats we have available. So how do we go about this? First of all, we want to look at what do we want to measure. For BGC argo, we want to look at the phenomenology. Basically, what are we trying to characterize? These are just examples, but they're important ones, showing air-sea carbon flux, showing where carbon might be changing in the ocean and the anthropogenic carbon at the bottom there. Looking at what's below the satellite measurement of chlorophyll, satellite ocean color measurements. Looking for what's happening in deoxygenation regions that we know about. These are our global patterns, and so this motivates our having a global array, and we want to make sure we get floats in each of those stories. We can also look at observing system design. This is just an example from some recent work saying, do we really need as many floats as Argo has? Argo's got 4,000. Ken already touched on this with quite a few new references, but on the right you can see if you only had oxygen floats, the green dots is what you would be able to map. But if you pair that with TS, you can map a lot better. So there are relationships between the variables. So that's how we get to the number of 1,000 plus or minus 200. Whatever, and still a lot of interest in elaborating on that observing system design. You've also seen a map like this on the left. Before you decide where to go, you want to know what's there. So this is a recent map of the nitrate sensor coverage in biogeochemical Argo. You see a lot in the Southern Ocean from SOCOM. You start to see a lot in the Northern Hemisphere starting to appear. We take that into account. You want to take the float age and the sensor quality, is it operating, sensor operations into consideration. So the right panel is an example of looking at a projection of float age to see where existing floats might be weak. So this helps us with deciding where to go. If we found a suitable cruise going someplace where we want coverage, this is an example from the Ravel from Barney Balch's cruise this past season for SOCOM. We may want to take in regional features, and I think it's absolutely essential to study the regional oceanography as you're putting your precious floats, very few floats, usually 6 to 10 floats, onto a ship and putting in the time and resources to manage that. So you may want to look at the eddy field and mixed layer depths and the carbon fluxes as mapped out there. You might want to look at vertical coverage of vertical structure of carbon and other biogeochemical variables. You may want to look at the bathymetry. Where are the fronts usually found? You can go to machine learning approaches using biomes or TS regimes coming from satellite or Argo data. Use whatever you can get your hands on to figure out where you need floats, because you're not putting a lot in. You may be covering 4 or 5 essential regimes in a given cruise. Look for that. You can also then look at, well, where are the floats going to go if I stick them in here? This is an example from our recent GO-BGC deployment in the Western North Atlantic. You can just use existing Argo trajectories to see where they would disperse to, possibly, if they go through your box. And we are extremely it's great that we have the whole Argo array ahead of us prior to us. On the right, you can use prior Argo trajectories to get a PDF, a probability of where a given float may end up. This you can find in it's Paul Chamberlain's tool that's in the ArgoViz visualization and data management for Argo. So how do we get them in the water? First of all, you have to find a cruise. So really the best way is to know people. So you connect with your colleagues, you connect with cruise planners, you connect with your program managers, you just keep your ears open. Our core type of cruise that we love to go on is Go Ship, because all of the biogeochemical chemistry is measured to the highest standard on them, and then we really don't have to supplement or consider whether we want to supplement on a cruise. So there's the Ghost Ship array. The disadvantage is that those ships only go every 5 to 10 years across any of those given lines. There's an Atlantic Argo planning group. There's a Southern Ocean Argo planning group. There's probably a Pacific one. There's starting to be Argo planning groups that we can join and be part of. So what do we need? What kind of research cruise is ideal if we have a choice? And Yui just beautifully covered float calibration and validation, true CalVal. As he said, sensor calibration is independent of the shipboard measurements that we make. And so therefore, what we can measure on the ship is helpful to check the calibration. He went through the details of the calibration. So we use the shipboard measurements for validation. And the bottom scatter plots show bottle oxygen, bottle nitrate, bottle pH versus float measurements. We can only measure from a ship for close to the first profile. We can try really hard to be close to a float, a year or two into its lifetime, but we're not ever guaranteed that. So that's why the calibration has to be independent of shipboard measurements. But this coincident profile really helps with knowing how well we're doing. The observations that we like to collect are for the biology, for the fluorescence and backscatter sensors, the HPLC and POC. We like oxygen, we like nutrients, nitrate especially because that's the sensor, pH measurements. Alkalinity is great, it often comes with pH. And if it's possible to get an optical profile from, say, an FLBB or in situ DIC measurements, those are great too and used. So we can do this. We've done it with SOCOM. There's a sort of 1 year in on the left into SOCOM. You see the array of deployment locations. That's from 33 different research cruises, deployed 204 floats, and to the right you see the where the SOCOM floats are this month. Out of the 204, we have 115 that are operational. This is because there's a lifetime. We've been doing this for 7 or 8 years, and we had a huge pandemic hit in our deployments last year. With that data, we can now start to map air-sea carbon flux circumpolar with SOCOM, and this is the goal, and everything else that goes with it, all those biogeochemical sensors. Just as an example of coverage, this is where we're going to go in the next 5 years globally. This is from Channing Prenn and Allison Gray et al. Want a big thank you for those 33 research cruises of opportunity. Every one of them involved a collaboration, a significant collaboration with a chief scientist or an agency that was operating a ship, and with the measurement groups on the ship. This is our current GO-BGC and SOCOM float array at the bottom in the Southern Ocean, and also around Hawaii. There's a couple of SOCOM test floats. You'll see SOCOM, including floats that are alive and floats that have already perished in the cyan. And you'll see in the Western North Atlantic our first GO-BGC deployments from this past March and April. Planning for the next 9 months. This is a kind of what, this is the sketchboard where, put our cruises on the map, see if we have enough floats, figure out where they're going, start to pick positions. And in purple in the south side of this is the SOCOM plans, and in the blues and sort of in the northern part are more the GO-BGC, but they're kind of mingled. I would say a lot of these have issues that we're having to consider with pandemic, whether we have port access in Australia, in Cape Town, and in Punta Arenas, for instance. So this is all kind of going to be, this is the stuff of our weekly meetings. When we go to sea, here's what we need to do. We have to figure out where the cruises are, where the floats are, find the ships, see what there is going with CTD Rosette operations. We prefer to have that science program on the ship so that we can get validation measurements. And we need to have somebody on the ship who we can coordinate with directly as the floats go in. For GoBGC and SOCOM, we can send someone to join the cruise if you have a ship available. We have a couple of manuals through SOCOM that we're going to migrate to GoBGC for float deployment procedures. There's always an engineer that goes to port and talks to whoever is deploying, the marine techs or science party. And we have written instructions for that. That engineer importantly checks the floats before they get on the ship after shipping them that long way. Their cleaning procedures and their deployment procedures. We also have a shipboard operations manual through SOCOM that will migrate over to GoBGC. A lot of this is similar to what you'd find in a GoShip manual, but this is specific to our support measurements for biogeochemical floats. And we can help you with what kind of sampling you might want to do in the vertical with log sheets. If you're working with us, then procedures for shipping samples back if we're doing shore-based analysis. So that's all available. We have data management. Tom's going to cover all the data management for the floats. So this is just for the shipboard measurements. We assemble the data sets. Sometimes takes a long time because we may have many different measurement groups. And we archive the data at the CCHDO. That's a mouthful. There's a website. It's a cruise-based data management. If you go on to CCHDO and search for SOCOM, you'll find all the cruises where we've archived data. There's a nice map there in the bottom. And we archive the HPLC, POC, and FLBB data at NASA CBAS. I'm sure other countries have different data management for shipboard data. So this is my very last slide. What do we need? We're always looking for cruise opportunities and looking for collaborations. There's a bunch of ships there. We have had a lot of different ships involved. And there's one of our wonderful collaborators from this past season, that's Barney on the right. So we're always looking for that. We want universal COVID vaccination and a healthy planet so we can get into ports and get the floats onto ships. And a separate thing that we'd like to push for this year is to do a lot more work on observing system design approaches, especially as we're going global. So thank you.